Okay. Have we worked with quadratic functions this semester? Jacob, how do we know that our equation is quadratic?
That's x squared.
Okay, if we have an x squared term. Okay? So we know, and graphically, what does it look like? A parabola, okay? A parabola opening up or a parabola opening down, okay? So we know that a quadratic equation is going to have an x squared term in it at the very least, okay? So we at least have ax squared. We might have a plus bx, and or we might have a plus c, okay? Okay. B and C have to be real numbers. A can't be 0, otherwise we don't have a quadratic. I don't think you have to write that down, but at least understand that ax squared plus bx plus c is a quadratic. Okay. And we've done a lot of work with transformations of functions. And really, x squared is a function that I have you transform quite a bit because we're very familiar with it. Okay? So, instead of working with quadratics in this form, thank you. Yep. So instead of working with quadratics in this form, I think it would be more beneficial for us, we just got out of our transformations unit, okay? I think it'd be more beneficial if it looked more like, shifts left and right, stretches vertically or shrinks or whatever, okay? So we are going to take quadratics that look like this, and we, if they're not already, we are going to put them in standard form. Okay? This is the standard form of a quadratic. Now I know that some of us may be attached to the first form for standard form, but when we get into conics, our standard forms are going to morph just a little bit more. But our book calls this standard form for quadratics. Okay? So we are going to work with this form. Why is this form so nice? Okay? Can you see our transformations? Okay? So Caden, this H and K, what are those telling us? Like with transformations.
The shifts upwards and downwards and right and left.
Okay, so H is telling us which way right or left we're going to have to go. K is telling us which way up or down we're going to have to go. So HK is essentially giving us where that vertex is. If we take our parent function that has a vertex of 0, 0, and we shift it horizontally H and vertically K, we have the spot of our new vertex. Okay. Now notice how it says x minus h, the quantity squared, plus k. Right now this is written as a shift to the right. If it was x plus h, it would be a shift to the left. So we're taking h, and really it's going to look opposite from what you see, right? X minus h means h is that coordinate, that x coordinate for the vertex. So I would encourage you to think about, am I shifting right or am I shifting left to identify that x coordinate, okay?
So like if it was like x minus h or an h equaled 1, so it's like x minus 1, the coordinate would just be 1, not negative 1?
Correct. But if it was x plus 1, the quantity squared, because we're shifting left 1. Was that your question, Joe, that I just answered? Awesome. Okay. Now, we talked about even functions being symmetric about the y-axis, and a y equals x squared is an even function. Well, when we move it away from the y-axis, it's no longer even. However, there's still some symmetry happening, okay? If we draw a vertical line through the vertex, we have symmetry. We could fold our parabola in half and it's the same on both sides. We call that the axis of symmetry. So that's always going to go through the vertex. And since it's a vertical line, we write it as x equals a number. Since it's going through the vertex, it's going to be specifically x equals h. Now, I'm having you write these down, but in no way do I want you to memorize the vertex is hk. The axis of symmetry is x equals h. I don't think you need to memorize those. I think we can logically think through what the graph looks like to get our vertex, and we can picture our graph and where that vertical line is to identify our axis of symmetry. Okay? I don't think you need to memorize these things, but you at least have them in your notes to refer to them if need be. Okay? But I want you to think about the graph. Okay? Now, a is a number multiplied outside the function, so we could have a stretch or shrink of some kind. We also could have some sort of reflection. Okay? So I want to talk about a being positive versus a being negative. With your hands, arms, show me what our parabola would look like if a is positive. Get a good stretch in before the pep rally here. Okay? And what about if a is negative? Okay, kind of hard for me to see because you're hiding behind your desks, but we have an upside down parabola. Okay, so something unique about a parabola is it has either an absolute maximum or an absolute minimum point. Notice how the vertex of this parabola is an absolute minimum point, right? It's the lowest point. There's nothing lower on my graph. For a parabola that opens down, our vertex is a maximum. Okay? That could be helpful in some sort of application situation where we're trying to find maybe a maximum or minimum. If we have a quadratic equation, we have the tools to be able to solve for either the maximum or minimum depending on the situation. Okay? And we'll look at something like that. Okay, so we've worked a lot with quadratics that look like this. Okay. So if a quadratic is not in this form, I'm going to ask that you put it in this form so that we can quickly graph it. Okay, if we have something like this, we talked about it, it takes us a matter of seconds to put that on a graph. Okay, if we have ax squared plus bx plus c, we don't really know where the vertex is. We don't know where that axis of symmetry is. We could be plugging in points forever until we actually have a shape. But if we have something that looks like this, we know the vertex, we know the vertical stretch or shrink, or maybe there's not one at all, and boom, we can graph it very quickly. So, if your quadratic is not in this form, then we have to put it there. Please write down this first example. Okay. I need to remind you of what we call completing the square. Now, this came out in our conversation about a week and a half ago as a method for solving for a quadratic. We're going to use it to rewrite a quadratic. So you have all learned completing the square, but I can say with confidence that we all need a brush up on it. Okay? It's been a while. It's not one that you use often, so it's not like you've been practicing it since the last time you took a test on it, right? Okay? So, first of all, we are not solving. We are rewriting this equation. Okay? When let me take a step back here. X squared plus 6x plus 9 is what we call a perfect square trinomial. Why do we call it that?
Because 3 times 3 is 9 and then 3 plus 3 is 6.
Okay, so we can factor this to x plus 3 plus x plus 3. So it's x plus 3, the quantity squared. Okay? So if we have a perfect square trinomial, we can factor it to this right here, which is a part of that standard form that we're talking about, okay? So if we don't have a perfect square trinomial, we have to force something to happen in order to be able to factor two factors that are the same, okay? So x squared minus 6x minus 1, can that be factored into x minus a times x minus a, or whatever? It is not a perfect square trinomial. So this is what we are going to do. We are going to have to add a number in order to force a perfect square trinomial. But can I just add a number to a side? No. Okay, so we have two possibilities to balance out. We can add the same number to both sides, which is something we often do. Or, what's our other option? Instead of adding the same number to both sides, we could add and subtract the same number to one side. Okay? Now, since we're not solving for anything, that's going to be what we're going to do. Okay? So we have x squared minus 6x minus 1. We are going to add and subtract the same number so that we are not changing our equation. We're adding 0, right? We're adding and subtracting the same number, so we're adding 0. Okay? Now, some of us can look at that and know what number needs to go in the blank. Okay? There is a pattern that happens every time with perfect square trinomials. Okay? I'll write this one back up here for you. Okay? Do you see this number right here? Okay? If we cut that in half, what would it be? 3. And if we square 3, what is it? Okay. So this number right here is always going to be b over 2, the quantity squared, where b, like we talked about, is that coefficient of x. Okay? So b is 6. Cut in half is 3. Squared is 9. Okay? So we are going to add and subtract 9, which means we're adding 0. But this is what can happen. Okay? We now can take x squared minus 6x plus 9 and factor it to x minus 3, the quantity squared. Okay? And then we have negative 1 minus 9, so we have minus 10. Okay? Now, there is one stipulation about completing the square. This will only work if our leading coefficient is 1. If our leading coefficient is 1, we cannot complete the square until we force it to be. Okay? But the leading coefficient must be 1 in order to complete the square. But, I mean, really, we have one line of work, right? Okay, 2 if you count this step right here. Okay? It wasn't overly excessive. Okay? And now that we have this equation, we can say, all right, I have a parabola that's shifted right 3, 1, 2, 3, 4, 5, 6, 7, 8, down 10. There's our parabola. Okay, the graph did not take very long. Okay, we're going to need to identify our vertex and axis of symmetry. Our vertex and axis of symmetry. Sophie, where's our vertex? Okay, 3, negative 10. Okay, I saw you kind of looking at the graph, and then her eyes gazed over here, right? You can use either one, all right? We shifted right 3 down 10, so our vertex is at 3, negative 10. I like that you looked at the graph first. Okay, and then our axis of symmetry. Lindsay, where would our axis of symmetry be?
Negative 3.
Okay. Okay. Something that I'm going to be pretty picky about. Okay. Technically, our axis of symmetry, Lindsay, is a line. So instead of just writing negative 3, I want you to write the equation of that line. So what's missing?
X.
Yes, x equals 3. Okay. That is something I will count off for, like on a quiz. Yes. Lindsay, they have a question for you. Is that positive 3 or negative 3? It's positive 3. That negative 10 was right above it and we got excited, right? Okay. So x equals 3 is our axis of symmetry. Okay. Okay. One other thing that the book is going to ask you to do in your homework tonight, which please plan ahead to do, because A, we have a very short quiz over it tomorrow, and B, there's a football game that some of you are attending tonight. Okay? Did you
Yeah, but it's at 6:30.
Okay. Be strategic about when you get your homework done. They're going to ask you to find the zeros. Okay? They're going to ask you to find the zeros. Now, yes, we started out with this problem right here, but we've done some algebra to get to here. Use all of the work you've already done to help you. When our equation is in this standard form, solving for zeros is really, really nice. Okay? So solving for zeros, we're plugging 0 in for y. Okay? Why do I say that this is really, really nice? Okay? What's the first thing we need to do to solve this equation? Okay, we're going to add this 10 over. Okay? Cool. Now we can square root both sides, which is what makes this nice. Okay? We move over that k value. We can square root both sides. Just don't forget that this would be plus or minus radical 10. So our zeros occur at 3 plus or minus radical 10. What would it mean if I had a negative under the radical? What would it mean about our zeros if we had a negative under the radical? They're imaginary, okay? If your parabola doesn't cross the x-axis, you don't have real zeros. Okay, so if that happens, don't freak out. It just means you don't cross the x-axis. Okay? Which you would already see from your graph if you graphed it. All right. On the next slide, there is a word problem. I want you to read it first and then copy down the equation. Read it, then copy down the equation. And I want you to just brainstorm together at your pod. What are we going to need to do to find the maximum height of Mrs. Homan's head? Just brainstorm. Don't do anything, just brainstorm. All right. right, so what ideas do we have? Emma, what did you talk about back there at pod 2? Okay, and completing the square would help us identify what? The vertex. Okay, so Emma thinks we need to complete the square by getting rid of that negative 16, and that's going to help us find the vertex. Okay, and the vertex is going to represent what? Eli, what is it going to represent? Why is the vertex helpful?
I can help you find your maximum.
Okay, we have a parabola that's opening what direction? Down. So the vertex is going to be the very highest point. So if we can find the vertex, we can answer this question. All right? Now, some of us are worried about that negative 16. So let's talk about what we would need to do. Okay? We can only complete the square if we have a leading coefficient of 1. So since our leading coefficient is negative 16, we're going to factor it out. However, please listen. Stop writing. Only factor it out of the x squared and the x term. Please leave that plus 2.5 outside of the parentheses. First of all, I don't really want to factor negative 16 out of 2.5. And also, it doesn't matter. Okay? We're going to need a plus k anyway. So I'm going to close the parentheses and leave it there. Okay? Now, when we factor negative 16 out of 48x, what's left over? Okay, negative 3x. So what we're going to do is we are going to add and subtract our mystery number. Okay. So remember that this is b over 2 squared. Ugh. That's okay. What is b over 2, first of all? 1.5. Yep. Okay, so I'm gonna say 3 halves for right now. We can change it, okay? 3 halves. 3 halves squared would be 9/4. Right? So I'm gonna write 9/4. Okay, now, am I adding 9/4 to the right side of my equation? I heard a no. I heard a yes. Or maybe I imagined it, either one of them, I'm not sure. But this 9/4, do you see how it's inside of our parentheses? What's on the outside of our parentheses? The negative 16. So this guy is being multiplied to negative 16. So when we fill in this mystery number, it's really negative 16 times 9/4, which would be what? Negative 36, right? So we're subtracting a negative 36 is what's happening. So when we come over here, we have negative 16 times something squared. This will always factor out to be x, and then whether it's subtraction or addition is up to this guy right here. And then b over 2 is always going to be what that's going to factor to. Okay? 3 halves times 3 halves gets you the 9/4. 3 halves plus 3 halves gets you the 3. Okay? So when we factor, so we have x squared plus bx plus, this is always b over 2 squared. This is our perfect square trinomial. It's always going to factor to x plus b over 2, the quantity squared. That's going to be our pattern. Okay? And so then when we do this, we have 38.5. Because we are subtracting a negative 36, so it's really like we're adding, right? Okay. All right, so now we are in standard form. Emma's group said we need to identify the vertex so we can figure out our maximum. So our vertex is at 1.5. I'm just going to change 3/2 to 1.5 so that we're consistent here, since our y value is 38.5. Okay, now we have to interpret what this means. Okay, so x and f of x. I want you to go to the sentence where it says what they represent. Okay, Taylin, what does x represent?
Time in seconds.
Time in seconds. X represents time in seconds. Joe, what does f of x represent?
Oh, it's in there.
Mm-hmm.
The height. Yeah.
The height of the ball. So, if I want the maximum height, which one do I care about? The y value, 38.5. So, Mrs. Holman, softball, reach a max height of 38.5 feet after 1.5 seconds. Those of you who are familiar with softball, was this one of her great hits or one of my bad hits? Depends on how far it went, right? If I just popped it straight up, it probably wouldn't be great. After 1.5 seconds, it probably went fairly far, I would hope. I've never hit it over the fence. But I have hit it in the park home run.
When we were first reading it, it said the batting cage. I thought it said the battling cage. It's like, she got a couple good hits in. I was like, what?
The batting cage. Yeah. I'm not a boxer. I'm sorry to disappoint you, Kaden. A secret teacher fight club. Okay, last 10 minutes we're going to spend on this problem. Okay. So, we've done a couple problems where we've completed the square and then identified pieces of the graph. Now we're going to go the other way. I'm identifying a couple pieces of the graph, and we are going to have to figure out what the equation is. Okay, so write down the information you think is necessary for you to remember back in your, like if you're referring to your notes, you get the gist of what's happening. And let's brainstorm again. Before we solve this out all together, have at your pod some things that maybe you think we can do with this piece of information to be able to write y equals a x minus h squared plus k. Go.
X squared plus whatever c is, and then we can go from that to complete the square.
Well, we know what h is. Yeah.
Which
Are you getting ready for your homework? Oh, okay.
And it is a parabola, right? So we want to find A would be the stretch, right? So if we plot that second point, we could probably figure out if it's stretched or not.
But not here, man.
Get the A.
just one
You just show us the plus. All right, so thoughts. Nathan, what do you guys think? Any ideas?
Well, we already know what the vertex is, and that means we already know what h and k is.
All right. Nathan says we know the vertex, so we already know h and k. So we know that this is x minus negative 6, the quantity squared, plus 15.
What?
I think you mean 4 and 11.
I think I do mean 4 and 11. What'd you say?
Don't have any questions on that.
If you have time, might as well.
Okay.
was still
I was looking at the wrong coordinate, wasn't I? Okay. So x minus -4, the quantity squared, then plus 11. Thank you for correcting me on that. The vertex.
So it's minus
Okay. Okay. Well, we have a good start. So we need to know A.
We could put that on a graph and then put the other 2 points on to figure out if it's positive or negative.
Okay, so graphically we can figure out if this is above or below to figure out if this is negative. Okay, that's good if it opens up versus open down. Kaylin, you have an idea?
You can plug in the point in the x and y and solve for it.
Okay, so if we want to know exactly what kind of positive or negative value that is, because it could be a 2, it could be a 1, it could be a 5.3 for all we know, okay? We can plug in our point to get the exact stretch or shrink that we have, okay? So we can take y is 15, x is -6, and solve for A. I'll give you a moment to do that in your notes. Please solve for A. Please remember your order of operations. What are you getting? 1? Are we getting 1?
Yeah.
6, -6 plus 4, the quantity square would give us 2 squared, which is 4. When we subtract 11 over, we get 4, so A is 1. Okay, that's kind of boring, right? A is 1. Not a very exciting quadratic equation, but since A is 1, we can say with confidence we have y equals 1 times x plus 4, the quantity squared, plus 11. Like that. All right. Don't put your notes away because I think I'm going to have you practice a problem since I didn't know if we would have time or not. But I want to practice at completing the square before I send you on your way. So first of all, please make sure you bring your graphing calculator tomorrow. These aren't all of your homework problems, it's changed. But bring your graphing calculator tomorrow because our notes are going to be some discovery with your calculator. So you get to plug in graphs into your calculator and make some observations. Okay? With our remaining time, I would like you to put this in standard form. And I want you to call me over to check it so I can make sure that you're doing it correctly. Okay. I don't mind if you talk to each other about it, so you can help each other. That's okay.
So you have to fill out the 2 first. So it's going to be plus 4. Because 4 times 2 squared is 4. So it's going to be plus 4 plus 7 minus 8.
Careful with this one right here. Remember this 4 is 1 plus 2. So you would want to subtract.
Because you have
it's two
Same thing,
times
you have
x plus 2
4,
y squared.
So if we have 4 times 2. Yeah. Yes.
Oh, yeah, you're right.
So because you gotta subtract that, you gotta
Two in parentheses are
Call me over.
minus 1.
Oh, yeah.
We're adding 4.
How was the test?
That was really bad.
Realize it's Thursday. Completely forgot.
It's almost Friday.
I'm still confused about
Okay.
the morning.
Yes. If you all have the same
I'll
thing.
be here
Yes.
before me.
Alright, so there's just no reason why we don't.
No, I know, but like,
She was like, she walks so slow. With the question, no, this is like, and I.
Okay, the biggest thing I wanted you to practice one more time. Do not forget that when you have a leading coefficient that is not 1 and you factor it out, then whatever you put here does get affected
I was wondering this, like this sense.
by that leading coefficient. So when you balance your equation, don't forget about it. Okay. We get out at 45, so we have about a minute for you to get organized and pack